I'd like to go through this problem that we started in class. This is an interesting Kirchhoff's law problem because it has a supernode here in the middle. A supernode is any time that you have a current source or a voltage source, whether it's dependent or independent, that's in between two nodes, and it doesn't have anything else, no resistors, in between these two nodes. We have to handle that in a special way. Let's say that we've been given our two sources, our voltage source and our current source, and all of the resistors that are in this circuit. Then we can use this analysis technique where we know that we have our sources, in fact we also know our current source and our resistors, and we can use Kirchhoff's law in order to determine the currents. So let's begin. The first thing that I'm going to do is this loop right here, minus Vs plus I1R1 plus I2R2 is equal to 0. Now let's do this loop. In this case, I'm going to put pluses and minuses on my currents. This would be minus I2R2 minus Vx, which is 3I2, plus I3R3 is equal to 0. I can't do any more loops because if I did this loop, it would have to go through a current source, and that's not allowed. So the next thing I'm going to do is a node. I'll show you the easy node, and then we're going to actually do a supernode. So here is one node, and that's actually the easy node to do in this case. If I did the pink node, I would have all of the currents coming in equal all of the currents going out. So what's the current here? The current in the branch is always the same, so this is I1. I1 is the same current in that whole branch. So the currents that are coming in are I2 plus I3, and the currents that are going out are I1 and IS. That's if I did the pink node. As an alternative, I could have done this supernode right here. Now, you'll notice that I actually have two nodes, but in between them is just a voltage source that has nothing else, no other resistors. So if I wanted to be able to do the orange node, for instance, I would have the current coming in, I1, and the current going to out here. But what current do I have there? I don't know. If I tried to do this node, I have the current going out, the current coming in, and what current is there? I don't know. So there are two ways of handling the supernode. The easy way, I think, is to define a current. Let's just call it Ix. That's the same current every place in that branch. And then I can actually do both this node and this node. Because I've defined this new unknown, I now need to find also Ix. So I'm going to need an extra equation. So as an alternative to this, I could do the orange node, which would be currents coming in, I1 is equal to Ix plus I2, and the other one would be what's coming in, Ix plus Is is equal to I3 going out. So this is the orange node, and this is the yellow node. So I have two different ways I could solve this problem. I can either use equations 1 and 2 for my two loops, plus my pink node, or I could use 1 and 2 plus my orange and yellow. These I would turn into a matrix equation. Let's do the one with the pink on this side. I would be solving for I1, I2, and I3. My variables would be I1, I2, I3. I would be solving for these equations like so. And then there would be a constant on this side. So it would be Vs coming over to this side, I1 times R1, I2 times R2, and 0 times I3. Here we would have 0 times I1 minus R2. Aha, there's a minus 3R2 there, so combine those two. So it's actually the I2 is going to have a minus R2 and a minus 3 right there. And then here is R3. Any constants? Nope, no constants over on that side. Right here I would have, let's get these all on the same side. I'm going to move these two over to this side. This was IS, not I3. I'm having a little trouble keeping track of that one. So here's I1, here's minus I2, and here is minus I3, and then over here we have IS. So these are the equations that we would solve in order to find our solution. Okay, let's go over to this side. If I wanted to do this set instead, I would have actually had 4 unknowns: I1, I2, I3, and IX. I1, I2, I3, and IX. And then over here's my vector of constants. My equation number 1 would be just the same: R1, R2, 0, 0, and Vs. My equation 2 would be the same: 0, minus R2, minus 3. This would be R3, 0, and 0. Here we would have, now we're replacing the pink with the 2 orange and yellows, so this would be, I'm going to move this over here, 0 is equal to minus I1 plus 1 times IX plus 1 times I2, and the yellow one is going to be 1 times IX. Let's move IS over to this side and I3 over to that side, like so.